Out in a dry interior of Queensland, there's a stretch of dusty hills where people spend their days digging through gravel. From the surface, it doesn't look remarkable. Just low ridges, scrubby grass, red dirt roads and the occasional rumble of machinery. But beneath those hills lies one of the strangest and richest gemstone landscapes on Earth. Scattered through the ground here are millions upon millions of sapphires, tiny flashes of blue, green and gold hidden in ancient gravel beds. Most people have never heard of it, yet this region once supplied the majority of the world's sapphires. And even today, the area known as the Central Queensland Sapphire Gemfields remains one of the largest sapphire provinces ever discovered. The fields lie about 45 kilometres west of Emerald in Queensland's Central Highlands. A cluster of small towns, Rubyvale, Sapphire and Anakie, mark the heart of the district. They sit in the middle of a vast area of sapphire-bearing ground that stretches across hundreds of kilometres. In fact, a gemfield covers roughly 900 square kilometres, which is enormous for a gemstone district. For comparison, many famous gem deposits around the world occur in single valleys or small river systems. Here, the sapphires are scattered across an entire volcanic plateau. The story begins deep underground, far below the surface where these gems are mined today. Sapphires are a variety of the mineral corundum. Corundum is simply aluminium oxide, a very hard crystal that ranks 9 on the hardness scale, second only to diamond. That extreme hardness is one of the reasons sapphires survive geological processes that destroy most other minerals. But the real mystery isn't their durability, it's where they came from. In Eastern Australia, sapphires are closely tied to ancient volcanic activity. About 20 to 50 million years ago, this region experienced widespread basalt eruptions. Basalt is a dark volcanic rock that forms from magma rising up from the mantle, the deep layer of the earth beneath the crust. When that magma punched its way toward the surface, it sometimes carried crystals along for the ride. Think of it like a geological elevator lifting minerals from deep underground. Geologists believe the sapphires formed much deeper in the earth, probably in the low crust or upper mantle. The lower crust is the deepest part of the continental crust, while the upper mantle sits just beneath it. Under those extreme temperatures and pressures, aluminium-rich rocks can crystallize into corundum. When later volcanic eruptions occurred, the ascending magma ripped fragments of those deeper rocks free and transported the crystals upward. But the sapphires didn't remain inside the volcanic rocks forever. Over millions of years, the basalt flows that erupted across this landscape slowly weathered and broke down. Rain, rivers, and erosion gradually dismantled the volcanic terrain. Most minerals in basalt decompose fairly easily, but sapphires are incredibly resistant to weathering. As the rocks crumbled away, the sapphires remained behind like tiny indestructible relics. Eventually, rivers began concentrating them into gravel beds. This process is known as placer formation. A placer deposit forms when heavy, durable minerals accumulate in sediment as water transports and sorts the material. Gold deposits often form this way, and sapphires behave similarly because they are both dense and resistant to erosion. Over time, ancient river systems concentrated the gemstones into layers of gravel known locally as wash. The wash is the layer miners chase today. It's usually a thin band of gravel sitting on top of clay or basalt bedrock. Sometimes it's only a few tens of centimeters thick, but it can contain thousands of gemstones per ton of sediment. Finding that narrow layer is the key to mining the fields. By the late 19th century, prospectors began noticing colourful stones in the creeks and soil around Anakie. At first, there was confusion about what the minerals actually were. Some early miners believed they had discovered rubies, which led to the name Rubyvale. Eventually, it became clear that most of the stones were sapphires, though the name of the town remained. Once word spread, a sapphire rush began. Throughout the early 20th century, thousands of miners moved into the district. Unlike many gemstone fields elsewhere in the world, the deposits here were not confined to a single valley. They were spread across an enormous area. Prospectors sank shafts, dug tunnels, and scraped away hillsides in search of sapphire-bearing gravel. That tradition continues today, although modern operations have become much more mechanised. One of the largest industrial projects in the region is the Capricorn Sapphire Mine. Unlike the small claims operated by independent miners, Capricorn is designed as a large-scale open-cut operation. Open-cut mining simply means removing material from the surface downward rather than tunnelling underground. At Capricorn, excavators first strip away the overburden. Overburden is the soil and rock that lies above the valuable layer. Once the miners reach the sapphire-bearing wash, the gravel is dug out and transported to a processing plant. That's where the real work begins. The gravel is fed into a washing system, often a trommel or screening plant. A trommel is a rotating cylindrical drum that separates materials by size as water washes through it. The process breaks apart clumps of clay and allows the heavier minerals to settle out. Because sapphires are denser than most surrounding sediment, they tend to concentrate in the heavier fraction of the material. After washing, the remaining concentrate contains a mixture of heavy minerals. Along with sapphires, miners often recover zircon, garnet, spinel, and other gemstones. These minerals formed in the same volcanic environments and were transported alongside the sapphires. The concentrate is then sorted, sometimes by hand and sometimes using optical sorting machines that detect the gemstones. What makes the Capricorn project particularly significant is the scale of the resource. Geological surveys estimate that the deposit contains tens of millions of carats of sapphire-bearing material. A carat is a unit used to measure gemstones, equal to 200 milligrams. When you start talking about deposits containing hundreds of millions of carats, you're dealing with one of the largest sapphire resources on Earth. But the real giant isn't just the Capricorn mine, it's the entire Central Queensland Gemfields. This region represents one of the largest known sapphire provinces anywhere on the planet. During parts of the 20th century, Australia supplied as much as 70% of the world's sapphire production. That's a staggering number for a gemstone industry that many people outside the region barely know exists. Another fascinating aspect of these sapphires is their colour. While many people imagine sapphires as deep blue stones, the gems from Queensland often display a mixture of colours within a single crystal. These are known as party sapphires. A party sapphire might show blue, green, and yellow zones all within the same gem. This colour zoning happens because trace elements, tiny amounts of other atoms within the crystal structure, change during the growth of the sapphire. Iron and titanium, for example, influence the blue colour of sapphire. If the chemical environment shifts while the crystal is forming, different colours can develop in different parts of the crystal. The result is a gemstone that almost looks like a miniature landscape of colour frozen inside a single crystal. Even today, the Gemfields maintain a unique mix of industrial mining and old-school prospecting culture. Around Rubyvale and Sapphire, you can still see miners operating small claims, washing gravel with homemade equipment, and searching for the next big stone. At the same time, companies like Capricorn are bringing large-scale mining technology to the district. The landscape itself still bears the marks of more than a century of digging. Old shafts dot the hillsides, some descending 10 or 20 metres to reach the sapphire-bearing layers below. These tunnels were once hand-dug by miners, following ancient river channels through the ground. Today, they stand as reminders of the long and often unpredictable history of gemstone mining in a region. What makes the Central Queensland Sapphire Gemfields so special is the combination of geological events that created them. First, the deep formation of corundum crystals under intense heat and pressure, then the volcanic eruptions that transported those crystals toward the surface. After that, millions of years of erosion breaking down the volcanic rocks. Finally, ancient river systems concentrated the gemstones into the gravel layers miners search today. It's a geological chain reaction stretching across tens of millions of years. If any one step in that sequence hadn't happened, this remarkable sapphire province might never have formed. So when miners dig into those dusty hills west of Emerald, they're not just removing gravel, they're uncovering pieces of a story that began deep inside the earth long before humans ever walked across this landscape. Tiny crystals forged under extreme conditions, carried upward by volcanoes, scattered by rivers, and finally gathered by people searching for flashes of colour in the dirt. And that's why this quiet patch of Queensland remains one of the most extraordinary gemfield regions on the planet. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.